my name's Greg Freeman. I'm part of the team at Clean.ai. I decided that Matt should speak about the automation of data engineering because everyone loves a slightly controversial topic for a digital week. So I'm sure there'll be some interesting conversations stimulated. It's not loaded from our side. It's just a topic that we love to talk about in terms of automation versus human capital in data engineering. I'll introduce Matt so he doesn't have to introduce himself because he always gets a bit embarrassed. So Matt is one of the co-founders of Clean.ai. He founded it in tandem with Andrew Thomas, who was formerly in charge of data at Not on the High Street. But Matt himself was, in his last role, Chief Data Officer at Trainline.com. Previous to that was head of BI and the analytics function at Just Eat through their IPO. And also in between that, sandwiched it with a chief data officer role at what is called Momondo Group, but is actually better known in the UK as cheapflights.co.uk, who exited to Kayak for ballpark £550 million a few years back. So speaks from a position of some authority within the space. Yeah, it's an interesting topic. So put your questions in the chat and we'll open it up to the floor in a round table at the end.
Awesome. Thanks, Greg. Much appreciated. It's always nice not to have to do that intro bit myself. So yeah, right. I am reliably informed that the audience today is well informed on the sort of data space. So I'm going to whistle through the agenda now and just sort of set the scene a little bit. So I'm going to start off talking a bit about the data challenge itself, what it is that we're actually sort of automating here when we say automating data engineering. As I say, I'll move fairly quickly through that, assuming a sort of reasonable level of knowledge on the call. So we'll then talk about how you actually sort of set about that, again in sort of reasonably sort of high level details. The options, build it, or what's the other one? Sorry, ignore the word done after each of those items. Editorial problem. Then I'm going to talk about why we feel that software is better than people for this. Hence the controversy. So hopefully we'll stimulate some conversation. I'm going to talk about where data engineering is really required and where actually we feel that it really should be applied, and then we'll dive into those Q&A. So I really want to get through the presentation fairly quickly and get a conversation going. So start off as a bit of a webinar and turn it into a bit of a roundtable is my aim. So we'll see how that goes, see if we can achieve that, and see how talkative you lot are feeling. All right, so what are we talking about? I'll just set the scene, as I say. BI, business intelligence, analytics, whatever it is you want to call it. The way I think about this is really the what has happened. That's you reporting and dashboarding. You're looking back. It's a matter of seeing what the trend is and hopefully looking forward from that. And that looking forward is really the why has it happened and what are we going to do as a result. And that's really where I'd lump your analysis and insight. The derivation of that is really asking those questions, and that of course feeds into the sort of what if, the scenario planning, and with I'm thinking modelling and forecasting predominantly. So yeah, scenario planning, projecting forward, your linear regression, your probabilistic modelling, etc., etc. So think of it as analytics plus. It's sort of getting into the more advanced techniques, and then utilising data as an asset. So this is really where I put machine learning, AI, data science, and turning data into product. Really quick example from my Trainline days. So if you utilize Trainline, you book a ticket on the Trainline app. When you go to get on that train, it may well ask you whether the carriage is busy. Are there any seats on this carriage? And it will also tell you as you're going to that train where to get on the train to maximize your chance of getting a seat. Now, that is the output of a significant piece of data science work that was done at Trainline, pulling data from Twitter, pulling data from news feeds, doing sentiment analysis on pulling out words like utilizing NLP, pulling out words like delay and frustrated, angry, late, these kind of things, and establishing the sort of state of the trade network at any given moment, and feeding that data back to the user within the application, so you can obviously leverage that data as an asset. So why would you do all this? Again, I'm sure I'm teaching my grandmother to suck eggs with the current audience, but as I say, I do want to set the scene so we know exactly what it is we're talking about. I think there's an expectation in 2020 from investors, from shareholders, that data literacy is a thing. So the inaccuracy of data, or the absence of data, breeds mistrust internally, and I'm sure we've all got stories to tell on that front, being in those meetings where you argue about whose number is right. That absence of a single source of truth is often a painful one to bear. Organising your data well, pulling it in from all sources and centralising it is a way to really expose the gaps in the data. So instead of second guessing whether your ERP system, your CRM system is well implemented, actually putting the data out and properly laying it out and seeing where those gaps exist is always a good approach. And this is a really critical one for me. By democratizing data and pushing the ownership of that data through good reporting and automated reporting out to the functions, you get your time back as a data professional to actually spend on the second, third, and fourth items on the previous slide. Your analysis, your forecasting, your insight derivation, your data science. You can almost never get to that if you're constantly on the back foot, being reactive to inbound requests. So that's my experience throughout my career so far. So getting ahead of it and becoming proactive is really the goal. So how do you do this? Really high level, and this is really where I want to spend some time. So many symptoms, one cause. You've got a data problem or a reporting problem in finance. You've got an absence of attribution modeling in marketing. You've got poor visibility on conversion rate in your web-based product team. They're all actually symptoms of a single cause, which is the absence of a single source of truth and data being siloed. So any data source could be tightly defined as a data silo, so your CRM, your ERP, etc., etc. Combining that data together, pulling it out of those silos and combining it together in a single source of truth it makes it orders of magnitude more powerful. So you can imagine that you've got customer data sitting in your marketing tools, your Facebook ads, your Google ads, in your web tracking software, in your transactional database, in your CRM system. Combining all of that together and building that single source of a single customer view, it makes it infinitely more powerful in terms of optimizing product, optimizing marketing strategy, etc., etc. So building that single source of truth is really critical, and centralizing the logic is the key thing. Calculating those metrics in one place and then pushing that out into the business, rather than having revenue calculated in 4 different ways in 4 different departments. So uniting that stuff. Examples of data silos, just to really kind of hammer that point home. Anything that produces data and stores data is by definition a data silo. What does that look like? What does a solution to this look like? So I think if you think of all those data silos as producers on the left-hand side, super high-level architectural diagram here. In the modern world, we're talking extraction and loading. Get it into a data store, a central data lake, data store, whatever it is you want to call it. Typically in the cloud in 2020. Apply your data modeling, which is really your business logic, the rules that combine the data from those different source systems into something meaningful, and build a curated data warehouse in that way. Plug that into your BI tool, your Tableaus, your Lookers, Power BI, whatever it may be. Use that BI tool to produce your reports, and as the first port of call for your analytics. Also empower your analytics teams, your data professionals, to get straight back into that data warehouse, be writing SQL against that data, and data science efforts looking at the big data that's stored in raw format in your data lake. Pretty standard setup. The kind of technologies obviously that we're talking here across the 3 major cloud providers on the screen there. So Amazon, you've got Redshift for Snowflake, Google, BigQuery or Snowflake, Microsoft, Synapse for Snowflake. So that's the sort of architectural, very high level architectural approach that that certainly we'd recommend taking to centralizing, creating that single source of truth. But what are the different methods? And let's get into the meat of what we're talking about today. Different methods of approaching that. So if we look at this in a sort of left to right flow diagram, option 1, data engineering, engineering tooling, be that Python, Spark, whatever it may be that you're utilizing to manipulate data. Maybe you've got Airflow across the top of it, open source tooling, Data Factory in Azure, Amazon Glue, whatever it may be, to get that data piped in and centralized, and bespoke engineering tooling to get that stuff done. Option 2, you could outsource this thing, you could black box it, chuck it to a consultancy, and get the result out the other end. So option 1, I'm really thinking that is, I don't want to sort of poo-poo it completely. I think this is an absolutely applicable route for large businesses with very specific and bespoke data challenges. And I'm thinking people like, you know, you'd expect a Facebook, a Google, an Amazon, Uber, people like this to, of course, engineer their own data pipelines to meet their bespoke and specific requirements. Option 2, if you've got a singular use case for data, then going the consultancy route, going to a data science consultancy and asking for a solution to marketing attribution is the one I keep mentioning, let's say, then that's absolutely a potential viable option. And the final option, I think, as we sit here in 2020, modern automation in that engineering space, plus the analyst, plus the BI tooling. And really, what I want to talk about today is the comparison of option 1 and option 3, and why I think that option 3 is the route forward, and why we've built the business I now sit in. So option 1 is the route that we took at Just Eat, the route that we took at Trainline, and it was that experience, exactly as Greg said at the top, that experience that was inspiration behind me building the business that I've now built, which is all about automating that stuff away. Allowing data engineers to move on to better things rather than building pipelines of data. So this is my thesis. Software beats people in this space. Everyone's solving the same problem. This was very, very clear from my experience. I did it at Just Eat. I went on to Momondo, did the same thing, went on to Trainline, and started thinking this is like Groundhog Day. I'm hiring engineers, I'm throwing tooling at them, they're selecting the tooling they want from that set, they're going off, they're building it, rinse and repeat. You only have to do that so many times before you think that maybe this is an opportunity. The fact that everybody is solving this from the ground up again and again means there's probably a better way of doing that. And this is all about automating the repeatable. Where people are doing the same thing over and over again, it means there's a commonality of purpose, and there's got to be a solution there. And software is all about automation. People are better than software in certain aspects, right? So this is not about removing people from a business. This is about moving people to the place where they're of value. And I'll come back to that in more detail shortly. In my experience, engineers hate the mundane, the repetitious, the pick data up from this place and put it in that place, build a pipeline connecting these two things. That is not what engineers want to come to work to do. It's about solving the novel challenge, I think, is the thing that retains talent and actually is where people are better than software, clearly, solving the novel challenge. And on the flip of that, analysts hate terrible data. You'll always hear that stat quoted. 80% of a data professional's time is spent wrestling with data. This is exactly the challenge that you face. My experience is one of analysts over here on the right hand side, engineers over here on the left hand side, analysts requiring stuff from engineers, then communicating, and that communication being a source of friction. They're not talking quite the same language, business facing, non-business facing, etc., etc. That's the challenge that ultimately inevitably arises from a human data engineering solution to this challenge, to this space. By instead automating the engineering, lowering the barrier to entry on those technical challenges, you allow the analysts to own it end to end, own the full stack, leverage their analytic capability on that raw data to move it all the way through that pipeline that we had on screen a moment ago, and get to the analysis, get to the automated reporting quicker. So that's ultimately the thesis I'm presenting. And what that allows you to do is free data engineering up and move it to where it's really needed. And that is all about product data from source. So if you're, and again, I'll talk from my own experience, at Trainline, one of our main sources of data was, of course, the Trainline platform itself. That platform produces data of huge value, and outputs that data in technical format. It's nested JSON objects that requires a whole bunch of work to unpack and turn into something business usable. The quality of the data that was output from the product was hugely variable. And that's because we didn't have data engineers, people with data at the core of their skill set and core of their interest, actually near the source, defining what came out of that. And that just meant that the work downstream with that data was way harder than it needed to be. I think the other area where data engineering is critical, and what you're seeing more and more, is data scientists moving into the data engineering space, actually, because thinking about the BusyBot for Trainline, the application that I described earlier, it starts as a data science project, but then needs to be turned into a product. And that is really data engineering. That is turning something proof of concept into something fully fledged, end-to-end, robust, piping of very large data into the correct applications and correct resources that can then utilize that data to produce the desired output. That's really where you want to be deploying your data engineering skill. So I think by combining your software engineering and your data engineering in those spaces, that's where you really truly become a data company. It's where data is the product itself, or is certainly leveraging the product to its full capability. And as I said before, analysts can own that data platform end to end. In this modern day and age, data storage is very cheap. The movement of data from one area to another is a common challenge, and there's technology out there that allows the automation of that. And that's really the argument I'm making, that you don't need data engineers doing that stuff. Software can do that. Data engineers can be deployed elsewhere. So that is my thesis. That is my, me sticking my neck on the line. I know it's a controversial topic, and Greg and I talk to people all day, every day on this, around this topic. And in our experience, people fall into two camps. They either love this idea, love the idea of empowering analysts to own the space, or they hate the idea. And actually, they are all about leveraging individual engineering technologies, individual engineering teams to continue to own that space and build something bespoke. So I'll throw the floor open. Greg, have we had questions?
Yeah, we've had one question so far, so I'll start with that one to give everyone else a kind of minute to think about any questions they may want to ask, either in the chat, or if we do throw it out to a bit more of a roundtable kind of vocal conversation. But Howard has asked, how do you, in inverted commas, let the analysts own the data?
Yeah, it's a really good question. I've whistled through that incredibly quickly, and there's an enormous amount of devil in the detail here. But ultimately, what we're talking about, if we think about it from a skill set point of view, the reason that analysts can't own this now is the technical barrier to entry on it. So the engineering tasks that we're talking about, if I go back to this slide here, the engineering tasks we're talking about, this extraction and loading, this transformation, they require, in an engineering framework, they require skills around DevOps, standing up of infrastructure. They require skills around scheduling, dependency management. So the interaction between the job that pulls data from a source and loads it into a lake, the job that picks that data up from that lake, combines it with some other data from that lake and turns it into a single customer view, say. That there's obviously interdependencies there. All of that stuff traditionally requires data engineer to build the framework in tools that are specific to an engineering approach. Analyst skills obviously exist downstream of that in the sort of visualization space, the SQL space. So it's that technical barrier to entry. And what we're saying is that by actually building technology that handles the heavy lifting of the connection to the API, the connection to the database or file store, or whatever your source may be, the scheduling and extraction of data from that source, the subsequent transformation and data modeling and all the dependency scheduling around that, all of that stuff can be solved with software. Software that has an easy to use interface on the front end, which means that an analyst has access to all of that part of the stack. So in fact, they're empowered to go straight from data source through to report or insight, all in a single tool, just using the technical skills they already have. Technical skills of analysis and ability to write SQL is ultimately what that comes down to. So there's tools out there that empower that. So I suppose the question back to you guys is what's missing by taking that approach that you would have from an engineering approach instead.
So this actually, there'll be some crossover in this in this next question. It's come in privately, which is why everyone's not seen it yet. But Alan has asked, and he's absolutely right to start off with. So that's the important thing. Data engineers automate things. They don't do it manually. How does this differ from what an engineer would do? I.e., this sounds very config heavy. A demo might answer it, I suppose. Obviously, the last bit is not super relevant, but yeah, it sounds very config heavy. How does it differ from what an engineer would be doing anyway?
Yeah, so I think you're completely right. Data engineers in this space automate this stuff. I think the challenge that you've got with that, and I touched on it very briefly, is that interface between analysts and engineers. So data engineers are building pipelines, transformations, the stack that you see on screen. They're building that to sets of requirements that come ultimately from analysts, ultimately from the business via analysts typically. And what you inevitably get there is a non-lossless interface, let's put it that way, between analysts and engineers. So by actually allowing the people who are close to the business the ability to own the entire piece, knowing what is required as an output, allowing them to actually go and solve that directly themselves, I think hugely accelerates that process. The end result is the same, right? You are going to get to a solution with any of these options, but it's all about ownership and moving people to where their strengths are really beneficial. And analysts are the people who understand the interface between data and business, versus engineers who really are understanding the interface between technology and data. I would say is maybe a way of thinking of it.
Okay, cool. So 2 questions have just come in, and I'm going to go back to Charlie's because I think Charlie's actually asked a question that I'm probably better to answer than you. So I'm gonna ask this next one while I think about my answer to Charlie's question, because it's more of the kind of conversation I have on a day-to-day basis. I'm going to try and kind of squash Justin's question down because it's quite a lot of information, but I'm going to try and make it like digestible by the audience.
Do you want me to ask it? Sorry.
Yes, that would be excellent.
Because reading it back when I was typing it on a small screen, I suddenly realised actually this doesn't maybe make as much sense as I thought. The point I was trying to make is if data quality is poor coming into the process, the data engineers I work with are often spending a lot of time dealing with exceptions because they're using other tools to automate some of this stuff. And my concern when we talk about this kind of stuff is that people think that this kind of thing is a silver bullet to solve all problems, whereas what I was saying is, you know, this has to be part of an overall transformation and uplifting data literacy and accountability from my perspective. And I kind of wanted to get other people's views on this, because I'm constantly dealing with people who say, why don't we just do this? Why don't we just do that? And it's like, because it's not going to solve all your problems.
Yeah, absolutely. Yeah, it's a really interesting point. I think let's go back to the architectural side. There's a huge amount of detail hidden in this box with this single word in it, transform. Your data transform is the things you're actually doing there. It's data cleansing, it's joining, it's aggregating or disaggregating, it's unpacking nested data. It's a whole raft of different things, and within that is the exposure of data quality, good or bad, and of course you end up with ideally you end up with this sort of virtuous cycle here where talking back to a previous point I made about exposing the gaps in your data, it exposes that poor data quality. And no, you're completely right. It's not a panacea. You're not going to just suddenly solve all of your data quality problems. But I think it sort of possibly reinforces my point that by enabling this stuff to be the engineering bit to be sort of commoditized and owned by analysts, you free your data engineers up to move upstream, closer to data source, and actually resolve those data quality challenges at source, where that's possible. Does that make sense? Do you agree with that, or is that maybe controversial?
No, it's not controversial to me. Again, I'll let other people chip in as well. I think what I was trying to say is that what would you say the prerequisites are for being able to do this successfully? Because I think probably there would be at least some forethought that would need to be put in before you start automating some of this stuff, so you know what to automate and maybe what needs to be pushed back and say we need to think about this a bit more. Yeah,
great question. Love that. I think so. The way I would always approach an implementation like this, I think of it as top down and bottom up, kind of simultaneously. So the first thing, and again, I'll keep referencing this diagram, it's quite useful actually. The first thing I would set out to do is identify an exhaustive list of the data sources on the left-hand side. So what are the systems that produce data within the business? And what are the processes that go on around those systems? So, you know, CRM, ERP, whatever they may be, they produce data. Identify that as the sort of the bottom of this. And top down, you really need to engage senior stakeholders to think about what's the expectation from data. What are the questions that they're trying to answer that data can help with? And I think one of the really important bits is that data literacy shouldn't be assumed, and people will often tie themselves up with, you know, what the output is that they want from any given sort of bit of work in the database. Is it a report? Is it a piece of analysis? Is it a recommendation? Is it a bidding strategy? Is it whatever it may be? So actually helping people along that journey and starting with that data democratization piece, which is all about reporting. Ultimately, it's about mapping reports and through reports surfacing the right data to the right people. So the people who are making those data-driven decisions, or decisions that should be data-driven, have the data at their fingertips to feel confident and comfortable with what they're actually looking at. I think having either hundreds or thousands of reports across the business, and or a data team who are constantly reacting, inundated with requests, and a business that's pissed off with their data team because they don't get answers quick enough. I would say those are all symptoms of not having this stuff in order, not having a carefully structured set of reports which is an output from a well-executed data platform. So I think your minimum requirements is a clear understanding of what data you have and a clear understanding of what outputs are expected. That's going to allow you to fill in the middle gap with the right pipelines, the right transforms, and the right reports.
So my final kind of input on this before I let Greg go back to Charlie's question before Charlie gets bored and drops off. I
don't think Charlie can. He works for Qualcomm, I think. So.
Oh, okay, then that's good. So all I was going to say is, I think you've touched on a really important point there, which is this is all about what decisions are people trying to make, what action are they trying to take, and what that always leads me to is saying to people, so how do we want to do this? Are we looking at data within a specific domain, or are we looking at data that supports a specific set of decisions and actions that we're trying to take? And actually, what quite often happens is that the key stakeholders I'm dealing with in the business don't actually know. But from your perspective, would you say it's better to work on a domain to meet a set of requirements first so people see what is possible to do through the data, or do you think it's better to answer a specific set of decision criteria that might fit into the process? Does that make sense?
It does. I think proof of concepts are always very strong, and I think if you have a tightly defined outcome that people are after, the quicker you can get to that and build some credibility and build some goodwill, the better. So I think that is definitely a viable approach. The sort of domain piece that you mentioned, like should we focus on a specific domain and go after that in a kind of higher level way, I think is a really interesting one. It actually speaks to the structure of data that you would be materializing in a warehouse, and the way that certainly we always approach this, and the way that I've approached this with great success previously, is to think about the business and think about what are the logical domains that map data to the business. So I'll talk about Trainline again. You've of course got customers as a domain. You've got marketing interactions as a domain. You've got ticket purchases as a domain, journeys, groups of journeys, etc., etc. So these are logical domains for which you can build exhaustive views in the data. So you have what that actually looks like is a table for customers with a single row per customer with all of their aggregate information on in columns across the table. By building that stuff out, you unlock the ability to answer all questions, most questions that pertain to that particular domain, and you can do that in a really quite impactful way with a good BI tool. So I think back to a moment I had at Just Eat, actually, where we went in with a domain of orders, Just Eat orders, with senior leadership team, Tableau dashboard, one analyst, and we just started asking them questions about orders. So it was show us orders across the entire geography, break that down by cuisine type, break that down by customer demographics, and all these questions, all these slicing and dicing of data was just being asked live by that leadership team, me to start with, then the leadership team taking over, and the analyst was able to just, someone far better at Tableau than me, able to produce these impactful visuals on the fly to answer those questions as they came in. So it was a case of people didn't really know what it was they wanted to do with the data until it was put in front of them and they were allowed to just sort of free rein on that. So it's another way of helping people on that journey go from something that's very abstract for most people to something that is, you can actually realize the value of that quite quickly. Something that we call insight at the speed of thought. You think of a thing, you derive the insight straight away in a visual manner. So yeah, quite a rambly answer there, Justin. Apologies, but yeah, I think that domain mapping is great in absence of a very specific outcome that you could set out to achieve. I think it's a good way of doing it.
That's great. Thanks, Matt.
No worries, thanks.
Okay, I've had like a couple of really good questions for you coming from Slavek and Joe, and cool. They're brilliant. And obviously the question came in from Charlie, which I will let you feed into, but like I said, it's probably more the conversations I have. So if you already had a large data engineering team, how would you get their buy-in to adopt an automated solution? Yeah, I mean, fundamentally, it's probably, and I'm sure the engineering minds on the call itself feel this straight away. It isn't immediately viable to just say we're going to automate some of your work away. We've kind of simplified it down for you, and that's the reality. It's our best arena is a bit of a greenfield, or an arena where the old way's been tried and done, and it's not been as successful as possibly it could have been. So the end user, the consumer, the business decision maker is looking for a better way and a different way to what they've tried previously. But ultimately, in terms of an automated, a full, like an all-in-one solution like ours, that's obviously the challenge there. But as Alan said earlier, all engineers are looking to do is automate a lot of this stuff in a more engineering type mindset. So our way of doing automation, not always 100% popular with engineers. The idea of automating parts of this away, definitely popular with engineers. So it's about selecting the right tooling for an established engineering team, because otherwise it does become a more of a political conversation than a technical conversation. And we're not there to kind of ruffle those feathers. We want it to fit into places where, for instance, if the engineering team's heavily product-focused data, so they've been brought in to build pipelines for a technology product, and then the business has BI requests, then we'll happily go into that engineering environment, because ultimately we do a lot of the stuff that they don't want to be doing with business BI. So that's how you then sell it into an established engineering team, rather than replacing the work that obviously they were brought in to do. Anything to add on that, Matt, or back to the questions?
Yeah, I'll just add that in my experience, I've hired and run teams of engineers in this space, data engineers in this space. My experience tells me that having them solely occupying this kind of task, solving this stuff, it doesn't excite them in my experience. You know, these are highly skilled, highly valuable, very technical people who have an enormous amount to offer, and this is ultimately to plumbing, really. I think the stuff that excites them and really gets them to a point where job retention is a no-brainer is the productionizing data science initiatives. It's the being close to software engineers who are building tools that ultimately produce data in the first place. Actually pairing and pushing data engineers into that sort of space is the thing that they're right on the coalface. Then they're a vital part of the business. They're, rather than being sort of in the bowels of the sort of data pipelining. I think it's generally a more interesting area, and that's a skill that is hugely valuable in that space. So I think that'd be my answer to that. That we're not trying to remove people from areas of interest. We're trying to push them into areas of more interest, free them up from the mundane. That's really the message.
That is a really useful segue actually into Joe's question. So I'm going to skip to it first because it's very much linked to this. So Joe said, how do you feel about eliminating the creativity element by putting automation in? Some of the best engineers I know are immensely creative in their solutions to problems and can often bring a solution to the table that isn't the obvious one from a tech perspective. If everything is automated, will there be a gap left in terms of creative data problem solving? And the reason I've gone to that one is obviously because this then becomes actually the best use of an engineer's way of thinking is to fix these problems before they happen, rather than. So yeah, that's why I thought I'd go to that one next.
Yeah, so you touched on one point there, Greg, definitely. So and the short answer, the spoiler alert, Joe, I would say absolutely not. You in fact freeing them up to be more creative, because you don't need creativity to move data from a public API into a lake, and then the transform scheduling and so on. The whole reason that we're able to automate that stuff in software is that it's not a creative, a bespoke, ever-changing thing. So actually providing a quick and simple plug-and-play solution to that, I think, gives those immensely creative engineers, I love that description, by the way, gives them that time back to really indulge in that space. Whether that is, as I say, getting creative in terms of how to productionize a data science application which is consuming billions of rows of data and has to crunch that in super quick time, that sort of thing, or whether it is actually this is a really novel data source and we don't really know how to deal with the data in it. How do we get to a place where we can extract just the thing that we need, whatever it may be that requires human creativity? That, I think, is a direct benefit of automating the mundane. So yeah, I think that'd be my answer to that. Hopefully that resonates a little bit.
Cool. So now, just to give your breath a bit of your voice a little bit of a break again, Dan's asked a question about sales, so I'll probably answer, and then kind of I know a use case that I'd like you to use. So how would you sell the benefits to both non-technical and technical stakeholders who have tighter purse strings? And also, how would you counter the ROI versus ROI and benefits are worth the potential costs? Yeah, so obviously this is pretty much my remit in life. So I think the big point here is that most business stakeholders, technical or non-technical, whether that's a CEO and a COO or a CFO and a CTO, on probably the two sides of the spectrum, there's a general conception out there now from senior decision makers that if we could do data right, our business would be better. That's generally the foundation of the concept. And then how do we do data better? Well, the only way to do data better, really, or to do data properly, is one of the three options that Matt put up on the screen earlier. And I think everyone in this room probably will prefer the first or the third in most cases, but the second's obviously a very viable one too. The automation piece in terms of the ROI, the removal of like multiple engineers, or the fact that you don't need as many engineers, is obviously good for the purse strings, not bad. A lot of the models created by the tools that are doing the automation side of things, us and others, is that it's always cheaper than an engineer or a team of engineers. That's kind of the point. Like one of our best use cases in terms of the ROI piece that you asked about is that a business that we work with had 3 data engineers. They left quite quickly in a row, and Clean replaced the work they did. So they've not had to hire those engineers back for the pipelining piece. Now any engineering overhead they take on is purely for that creative thinking rather than the pipelining piece. So you've probably removed 2 lots of large London data engineering salary in exchange for a software. So that's where the ROI comes from, and it's a different way and potentially a more cost-effective way of delivering the right way of doing data. And Matt, if you want to talk about like my favorite example of data usage, probably the Just Eat one with Hungry House.
Oh yeah, okay, yeah.
If you can, I don't know if you can talk about this publicly, but
yeah, well, I mean, Hungry House has been bought by Just Eat many years ago, so yeah, cool. I think it's probably all fine. And hey, I don't work there anymore. So yeah, one of the outputs that we had from this, just demonstrating ROI of executing data well. We had a brief from a very brief brief from the director of marketing UK, who said the thing that was keeping her awake at night was how on earth did she win London, and that was the brief. So we had to first of all determine what winning in London would look like, and then how to actually set about that. So first of all, determining what winning in London looked like was, well, there's one competitor. That competitor was Hungry House at the time. So what's the actual lay of the land? She feels like it's competitive. We looked at it, and yeah, actually it was. Hungry House were quite competitive with Just Eat at the time. We did a bunch of data gathering and some combining, modelling, etc., and ended up, long story short, with for those of you who are a bit nerdy like me and have played Risk, the board game, we ended up with a sort of Risk type map of London with all the Just Eat restaurants and orders in a sort of heat map in green, and all the Hungry House ones in a heat map in red. And there were two bizarre kind of fronts, if you like, one right down the Old Kent Road in South London, and one along a road somewhere up in around Notting Hill, I think, from memory. So just this bizarre way that it ended up sort of appearing that there were just these sort of battle lines drawn. So then we looked at the demographic of the different areas and the different marketing campaigns and sales techniques that we could apply to try and win in those areas, and therefore sort of get the march on the competition. So ended up putting, I think it was banners on bus routes that ran up and down Old Kent Road, Just Eat banners. Got the sales team there to target all the Hungry House exclusive restaurants and give them zero commission offers for 6 months if they came over to Just Eat exclusively. Similar things, tube campaigns, out of home marketing advertising campaigns up in North London, and made those recommendations to the marketing and sales team respectively, came back and remeasured it 3 months later, and where previously there was red Hungry House, it was just a swarm of lovely bright green Just Eat. So the sort of recommendations off the back of that data analysis in the real world had a direct, very measurable impact, and Just Eat bought Hungry House maybe a year after that. That was the turning point. So yeah, just nice bit of ROI from the application of data.
Yeah. So Dan, what I'm getting there is that's the kind of dreamland that key decision makers are thinking they could get to with data. So that's the kind of story to tell them. Like, if we do this properly, if we do this as well as it can be done in whatever method we decide to do it, we can answer those kind of questions and have those kind of business wins, because selling it internally, technical or non-technical, is all just about business outcomes. So that's the type of story that would help with that. And if you want any more of those, then you can either reach out to Matt or I, and we'll help you with some of those others. Okay, the question from Slavek was really good as well. One challenge in automation, in my experience, is the necessity to reconcile multiple observations of the same real-world object, event, or phenomenon, each source of observations with its own level of accuracy and data quality issues. Sometimes these observations don't even have a signature or attribute-based connection to identifiable real-world entity that we can track. How do you approach combining data silos into a single data warehouse when this is the case, or when there's a lack of unique identifiers? I think, again, this comes back to the upstream creativity piece, but it's funny how much of it comes back to getting that side of things right.
Yeah, awesome question. Love that. I sense this might be a problem that you're facing right now, because it's obviously kind of super specific as well. Yeah, I think ultimately centralizing the data from those silos, even if there's not a common identifier between them and a way to stitch them together, you can create that yourself. So within that transform layer, create the bridge, create the lookup, the primary keys, however you want to define it, to create that common entity between them. Obviously, it's a bunch of work, but that for me is a really good example, actually, of exactly what Joe was getting at with the creativity, and exactly what Greg just hinted at there. It's an example of bespoke work that is needed, and actually this example, the solution I've just posited, of creating a bridge between them with create an additional lookup table or whatever to pull common keys together and bridge them together, could actually be done in SQL by an analyst. But equally, you could be building an additional transform job in there with some bespoke data engineering. Equally, if you have access to the source itself, if it's something that you own, then it's a good example of a gap being identified by putting that data together and being able to go back and say, actually, we need to track this thing and implement an identification, an ID, some sort of key at point of capture. Of course, it's not always accessible. So yeah, it's a matter of plugging that gap where you can with the tooling that's available to you. But I think you've got to create that ID where it's missing ultimately.
Cool. One more question's just come in, and obviously we've got about 5 minutes left, so do feel free to ask a couple more, which we should be able to get through. Akatu has asked, data engineers are a dependency in this context. By substituting for a brackets fully automated pipeline, what new dependencies will we be creating?
Oh, yeah, okay. Interesting. So, yeah, of course, you're sort of dependent on that automated software. It becomes a cog in the machine, if you like, and I think the onus is on a strong implementation which highlights the downstream dependencies, highlights the failure points, and put correct monitoring in to ensure it's robust. I think it's about the implementation of that, and I think you've got to be within that strategy piece that I talked about earlier, looking at the data sources, looking at the expected outcomes, ensuring that you are implementing in a robust manner to ensure continuity of service, to ensure that those dependencies are robustly bolstered, I suppose. It's probably, I think you'd need to get deep into specifics on that to really answer that in a less woolly fashion. But yeah, it's being cognizant of what those dependencies would be, which would be specific to the application, and making sure that you're implementing with those fully in mind, so they're highlighted, they're visible, etc., etc.
Rob's just said, interestingly, he's got to drop off, but interesting stuff, thank you.
Yeah,
Jazz has probably quite nicely summarised what we're trying to say, in essence, that I think I hear that the issue is everyone is focusing on the complexities where we need humans, which is definitely still exist, especially in a bigger infrastructure. The solution that we're talking about is freeing up the mundane tasks so the humans can focus on the complexities. There is always room for a library of automation scripts that are reusable. Absolutely, that's it. It's free up the get rid of the mundane and free up for the pretty. There is just put a question as well. If the scientists and visualizers can have access to the tasks without the engagement engineers, all the better. Controls and security information will be one of the challenges. Thanks. Yeah, it's less. It was more of a statement, but less of a question. But yeah, you can obviously dive into the controls and security of information and the metadata piece a little bit, maybe.
Yeah, I think good tooling should again lower the barrier to entry on this, right? Because previous roles I've had metadata and data dictionaries and that sort of thing, and security around data all managed externally to the tool that's actually automating this stuff, which is the moment you've written a data dictionary in a conference page, it's out of date and it's not going to be maintained despite all the best will in the world. So actually having it right next to the tool that is performing the transform, the extract and load, etc., I think is the way to do that. Have it as part of that process, part of the definition of done, and the process and workflow of implementing this stuff.
Cool. Okay, so Jonathan's just popped back up, and it's absolutely the right time to do that. There's a few more people dropping off now. As we've obviously made very clear, we believe heavily in this, and if you guys want to talk to us about it in any context, you can get me at greg@clean.ai, and Matt is matt@clean.ai, or I'm Greg Freeman on LinkedIn, and Matt is Matt Sawyer on LinkedIn. We'd love to talk to you about it. If anyone feels like they want to understand it better by seeing it, we're obviously open to that too. Even if it's just for exploration and to tell us we're wrong. So we're open to that too. So yeah, but really, honestly, thank you very much for everybody joining us, and it's very much appreciated.